we are at number 3. And remember, we are only focusing on the calculation question. This is us. We're focusing on the calculation questions. We want them so much. We want the calculations. So here, define, no, blah, 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 blah. Explain what is meant by center of gravity. Don't worry, we'll come back to you, my friend. But let's start with this one. Calculate the moment of the weight. The moment. Ooh, this is good. The moment we see they want moment, the formula for moment is force times distance. But remember, it will be perpendicular distance from pivot. So in other words, the distance, the direction you use for distance should be perpendicular to the direction the force is facing. I'll show you an example to what we mean. So let's say you have a pivot like this, right? So, and I'm going to have something like this, okay? So here's what I have, right? Here's what I have. Now, let's say my force is facing down like this, and I want to find its moment. Because it is facing down, which is in the vertical, that means I should check its horizontal direction from the pivot. Okay? I should check its horizontal direction in the X, because it is a force facing down and up. If it was facing to the right like this, I'll check its distance from the pivot like this. Okay? This distance, that's the distance I'll check, this one, which is the Y. That is, if it was a force in X, I'll check. So you always to make the distance go perpendicular to the direction your force is facing. So now let's talk about this force we have called weight. Remember, I always tell you, do not forget that weight is a force. Weight is the other name for the force of gravity. Okay? The force of gravity is called weight. Are we together? So now let's go for it. So weight, and we know that weight is a force weight is always a force, and it faces downwards like this. Okay? Weight is a force that faces downwards. It faces downwards from what? From here, from the center of gravity. It faces downwards. Do not forget that. So here is my weight. It's facing downwards like this. Now what do I want? I want to find its moment, so I should see its distance. Where is the pivot? I want its distance perpendicular to the pivot. You understand that? So now let's check that. So where is the pivot? They say the pivot is at X. So remember, because it is facing down, which is the vertical direction, you understand? Because it is facing down, which is the vertical direction, our distance will be the horizontal distance. Our distance will be the horizontal distance. Are we together? Horizontal distance. So that means we'll take this distance here, the horizontal distance. So we are checking its horizontal distance from the pivot. Do not forget that. When you're taking distance, make it perpendicular to your force. I know you won't let me down. I'm counting on you. I am counting on you. You will not let me down. So here, what is this distance? Weight. It's at the center of gravity, and it acts downwards. So it's right at the center. So that means to get from the center to the edge, it's half of this 3.4. They've told us that this distance, the thickness is 3.4. So we would say half of that. So we are going to say, what is the weight? They've given us the weight, which is the force. So our force is the weight. You can even see the units are newtons. So remember, moment is... So what were the things we needed to know in this question? Number one, the formula of moment. It's force times distance. Number two, to remember that weight is a force. And number three, to remember that distance is the perpendicular one. Okay? So what are we going to do? So our force is 1.3 times 10 to the power 7 newtons. And this is going to multiply the distance, which is 3.4 meters over 2. You understand? There we go. So it's 1.3 times 10 to the power 7 newtons. And this is going to multiply the distance. Let's put that distance. What's 3.4 divided by 2? It's 1.7. So this is going to be 1.7 meters. So let's multiply that. So we will now say 1.3 exp7. This is 1.3 times 10 to the power 7. And this multiplies 1.7. We are going to get what? We are going to get 21,100,000 rather. And let's change it to standard form. We'll just go 1, 2, 3. You do it with a pencil. 4, 5, 6, 7. 7, so it's 2.21 times 10 to the power 7. All right. Now, and this is Newton meters. That's the unit for moment. Now, what am I going to do? I'm going to do what here? I'm going to make sure it has the right number of significant figures now. I see this has how many SF? 1.3. That's 1 and 3. That's 2 SF. We don't count this. It's just standardization. So it's 1.3. And this other one, 3.4, which is 2. So my answer should also have 2. Okay, we should have our answer having the same number of significant figures as the guy in your calculations that had the smallest. I see he had 2, the other one had 2, so that means the smallest had 2 because both of them had 2. So that's like to say the smallest has 2. This one is 2.21 is 3, so we should throw away that one. Is the third significant figure, but before throwing it away, we see, is it a 5 and above? No. So that means we're just going to throw it away. So we can say the moment is equal to 2.2 times 10 to the power 7 Nm. So what is it? 2.2 times 10 to the power 7 Newton meters. This is going to be our moment, and we are done. You see how nice it is? And all these are from Unit 1. I gave you that formula for moment. If we go back to the top, where we were writing all our formulas. If we go back to the top of the paper, you can see the formula for moments there. And remember here, we didn't have to use the principle of moments because they didn't talk about something being balanced and whatever. Remember, when they say something is balanced, we would know that the sum of clockwise moments is equal to the sum of anti-clockwise moments. So we would get all the clockwise moments and would make them equal to the anti-clockwise, then we'd look for whatever we are looking for. But we don't have to do it right now. Here is our thing. Here is our, moment. Where is it? Here is our moment, and we are going to go to the next question, which we'll do in the next video. Goodbye for now.